Alright, here we have lesson 4 through 6 of Unit 3. And this is about the fundamental theorem of similarity, which you'll see in your book as FTS sometimes. And we're also going to look at what it looks like when we dilate things on coordinates. So let's start with getting down the definition of fundamental theorem of similarity. Alright, so the fundamental theorem of similarity says if you dilate 2 points from a center by a scale factor, a line drawn between the 2 original points and a line drawn between the 2 dilated points will be parallel. And that's just a lot of words for what I'm about to show you. So here we have an example below. We had points B and point C, and we dilated them out to become B prime, C prime. And you'll notice something. If we drew a line between B and C, and we drew a line between B prime and C prime, these two are parallel. That's exactly what we were just talking about in the fundamental theorem of similarities. It was talking about the fact that we dilated out these points, and then lines drawn between the original ones and a line drawn between the new dilated ones are parallel. So this line is parallel to this line. So let's write that out so we remember it. Line BC is parallel to line B prime, C prime, and this will be true of whenever we dilate out points, which is really cool because we know a lot of things about parallel lines, so now we can use that to manipulate things. Alright, let's keep moving on. Let's move on to the next page. Alright, so here we have point P and point Q that was dilated out to become P prime and Q prime. And we can actually probably figure out already what the scale factor is because the original was 5 in length and the dilation is 10 in length, so obviously it's a scale factor of 2 here because it doubled in size. But what we're missing is the center of dilation. And a lot of you can kind of think, well, we know it's going to be somewhere up here because everything got dilated out this way. And you're absolutely right. So all we need to do is essentially just connect some dots. So we're going to draw a line from P prime and P going up towards that area that we're pretty sure we know where the center of dilation is. We'll just continue it out. And we'll do the same thing from the other side, from Q prime to Q. And then we'll see where they cross. So they cross right here. Does that seem about right to be our center of dilation? Yeah, it actually does. If you notice also, you can kind of check it because P is a certain distance from our center and P prime is double that distance away, which should make sense according to our scale factor. So that is our center of dilation. And that's it for finding a center of dilation. Let's now take a look at what it looks like when we dilate coordinates. Okay, so here we have a triangle, ABC, and we have it on a coordinate plane. So let's write down the coordinates here. So point A is at 1, 1. Point B is at 3, 1. And if you're a little rusty with your coordinates, remember you go X first and then Y. So 3, 1, and C is at 3, 2. Okay. Now let's decide a scale factor. Let's do 2 as our scale factor. And of course, 0, 0 can be our center of dilation. That just makes things nice and easy. So we're going to scale things out by a factor of 2 from our center, which is at 0, 0 right down here. So let's take a look at what that would look like. So there's a couple different ways we can do it. So thinking about A is at 1 diagonal away from 0, 0. So if we're going to double that, then it should be at 2 dilations away. So here's 1 dilation, here's 2 dilation, should be our A prime. Okay. B is 3 over and up 1. So if we want to double that, all dimensions need to double. So instead of going out 3, we're going to go out 6. Instead of going up 1, we're going to go up 2. So that's where our new B prime should. And we can check that according to A. in the original, A and B are on the same line, and here A prime, B prime are also on the same line. So that kind of tells us we're going in the right direction. Now, for C, we have a couple options. We can either think about the fact that we're going out 3 and then up 2 and then double that, so it's out 6, up 4, which gives us right there. Or we can think about the fact that C is 1 above B, so C prime should be 2 above C. So that also gives us right there. So you can see that either way works. So let's go ahead and connect those lines. And there is our new figure, but we're not done. We want to look at the coordinates. So we just did the dilation, but we want to figure out what the actual coordinates are. So let's take a look at those. So A prime is now at 2, 2. B prime, let's see, is now over 6 up 2, so that's 6, 2. And C prime is over 6 up 4. Do we see anything significant here? So the first thing I'm noticing is if we take our coordinates from over here and double them, that's getting to be over here. So 1 times 2 is 2, 3 times 2 is our 6, 2 times 2 is our 4. So we're taking the original coordinates and doubling it. But does that make sense? Yeah, actually it kind of does. Our scale factor was 2, so it kind of does make sense that you take the coordinates and just multiply them by 2 to get our new coordinates. So we can actually find the new coordinates of something that's dilated without even doing the drawing, because we can go straight from having the original coordinates, multiplying it by our scale factor, and then there's our new coordinates. However, there is one thing that we need to know about this. This only works if your center of dilation is 0, 0. Okay? So let's write down what exactly we did. So we took our original and we multiplied it by the scale factor to get our new ones. Okay? So make sure you write down this part, because that's the important part that's going to show up so that you know exactly what you need to do each time. But remember, it only works if your center of dilation is 0, 0, because otherwise you're getting into really screwy numbers. And that's actually it for lesson 4 through 6 of Unit 3.